sequence is simply an ordered list of numbers. So in other words, numbers that form a pattern. Each individual number within that sequence we call a term. And then finally, an explicit formula. That's how I generally describe a sequence. And here for this stuff we use the letter N when we're talking about something general. So basically we'll be talking about finding the nth term. In other words, what is just some term in that sequence. What you see at the bottom of the page is a representation of what a sequence looks like. And what you need to be able to do is differentiate between the term number and the value of that term. Because you can see we use numbers to indicate a term number. And the way we would pronounce this is we would say a sub 1, where sub is short for subscript. So the first term in any sequence is a sub 1. This 1 doesn't represent the value 1. It represents where it is in the sequence. So it's the first term in the sequence. The second term would be given a sub 2. Again, it's not the number 2. It's the second term in the sequence. And then the third term would be a sub 3. That's the third term in the sequence. The numbers are going to change from sequence to sequence, the value of those numbers. But they're placed in line, maybe is a way to look at it. Okay, generally speaking, over on the right-hand side, this is how we refer to these terms generally. If we want to know what a particular term is, we refer to that as the nth term, or a sub n. The term that comes before that term is the a sub n minus 1 term. So if I have some pattern, and I say, what's the 10th term? A sub n. There, a sub n is 10. Think of it like a function. You know how you have f of x? So if I have a function, f of x is equal to 2x plus 3. Well, this is going to change. You want to know, okay, what's f of 3? What's f of 6? What's f of 9? We're not saying that x, what we're saying is that we're going to plug x in and get some number. Well, it's kind of the same thing. The n represents the term number. So this of a sub n minus 1 is what's the term that comes before that term. So if I say what is it, if let n be 10, my nth term is 10. My n minus 1th term is the 9th term. And then a sub n plus 1 would be the 11th term. Okay? Understand? Everybody doesn't understand. Because if you don't understand this, it makes what we're going to be doing all the more difficult.
So would you write 9 as a, was it 9 or a and minus?
Once you know what term you're talking about, you substitute the actual numbers. So yes, you would say a sub 9 is equal to whatever, a sub 10 is
What's the
equal
point
to...
of n minus 1 and n plus 1?
Just for illustrative purposes. Okay, so... Okay, so here is a table of values.
Write it down.
Okay, so here's a sequence, okay? Basically what what I want to know is what's the explicit formula. That's one of the vocabulary terms, explicit formula. So you'll be given a pattern, you'll be given a sequence, and what you have to do is you have to figure out what's the pattern. What are you doing each time to get to the next number? So one way to represent that is to create a table. So you can see what's going on. Now you don't have to. If you recognize what's going on, you don't need to make a table. But sometimes making a table lets you visually see what's going on in the problem. So what's going on here? Here's my n refers to the term number. So what's happening? I take my term number and I'm multiplying it by 2. And that gives me my value. My term number, I take my second term, I multiply it by 2, it gives me the value of my second term. Yes?
Just curious, why is it 2 that we're multiplying it by? Is it always 2 or something?
No.
No, so why this time?
This one is 2. We take the term number. Okay, term number 1. Okay? The term number is multiplied by 2 to get the value of the first term. Right? So the term number is not the same as its value. The first term is 2. Second term, the value of the second term is 4. You understand? This is my third term. Its value is 6. This is the fourth term. Its value is 8. This is the fifth term. Its value is 10. But what did we do each time? What did we do to the term number to get the term value? What did we do each time? Multiply by 2. So if I want to write a formula for this, so if I have some term number, what am I going to do to that term number to get the value? I'm multiplying it by 2.
That's what I was asking. Why is it multiplying by 2?
Because that's what the pattern is telling us to do.
Oh, okay. So we know the pattern for it.
In this case,
Okay. I thought we made the pattern.
that's what we're going to do next.
Cool.
Next, here's
I-
here's what we're going to be doing. First, I'm going to tell you this, right? And ask you to tell me this. Then, you're going to be given this, and you're going to figure out this. Okay, so we're going to start by being given the formula and asked to find the series. Then you're going to be given the series, and you're going to be asked to find the formula. Okay? Alright. Okay, so here's our first example. Here's how we're going to generate a sequence given an explicit formula. So you can see I'm given this, given that a sub n is equal to 3n minus 2. What I want to know is I want to know what are the first 10 terms of this sequence. Okay, so obviously the first thing you're going to do is write down the formula. Little 1 there. Second thing you're going to do is you're going to plug in 1. Because we want to know what's the value of term number 1. So we plug 1 in. When n is equal to 1, what value do we get? Just like a function. It's very similar to a function. The only difference is we're going to do it again and again and again rather than just once or maybe twice. So what do you get when you plug in 1? You get 1. You do not have to circle it. The circle is there for illustrative purposes. Its reason for being will become clear in a moment. You do the same thing again, except this time with 2. In other words, what we're doing is generating the first 2 terms of the sequence by plugging in. goal is to be able to generate the first 10 terms of the sequence without having to plug in. By understanding what the pattern is, and then doing that again and again and again. So when I plug 2 in, what do I get for my value? I get 4. And the 1 and the 4 are circled because we're now going to use that information to generate the next term and terms of the sequence. Now, without having to plug in, what do you think the next term in the sequence is? 7. What did we do? We added 3. To go from the first term to the second term, we add 3. And the term after that? 10. So if I want to list the first 10 terms, that's all I have to do, is keep adding 3. I need to do this, I need to do these first 5 steps to see what the pattern is. But once I see what the pattern is, I don't have to keep plugging in 3 and 4 and 5 and 6 and so on. Can I? Of course I can. If I don't feel comfortable or I don't feel confident that I figured out what the pattern is, and as a matter of fact, the book even suggests creating a table to organize your work. I don't necessarily think it's necessary, but some of you could use organizational skills. And that's how you do it. So that's you're given the formula and you are creating the sequence. Does anybody have any questions? So writing there, everyone? Yeah? Okay, I'd like you to do this one. Here's the formula. I'd like you to find the first 10 terms of the formula, and then also find the 20th term of the sequence. So, what's the value of the first term? 15. What's the value of the second term? 27. So what's happening each time? We're adding 12. So if we want to write the next 8 terms, instead of going through this process, all we have to do is add 12. So 27 plus 12, 39, 51, 63, 75, 87, 89, 111, and 123. Now, did anybody keep going to get to the 20th term? Well, Josue did. No, it's not 246. Check your math.
That's a wrong.
No,
243.
243.
Oh, I see.
20 times 12 plus 3.
Mrs. President, I had it right. I just forgot to change it.
Ah,
Which is why I had 1.3.
I see. Okay, does anybody have any questions? Okay, let's go on then.
Mrs.
Alright.
President,
What?
you said I did it the long way. What was the short way?
By just plugging in.
I did just plug it in though.
Oh, but I saw all those numbers written out all the way to the 20th term.
Yeah.
You didn't have to do that.
What I
Just multiply term, a recursive formula. We use a recursive formula to find the next term after a given term. field trip and FCAT.
We should stop.
No, we're not going to stop. I'm not going to stop teaching because other people are out.
But it's a lot of people.
That's not my problem. I didn't tell them to go on the field trip.
I have to. That's great.
So be it. The rest of us aren't going to stop teaching because we have a field trip. At least I'm not going to. Yeah, if there were 3 people in here, I wouldn't be teaching. So there's about half the class. 2, 4, 6, 8, 10, 12. Okay, so we want to know, so here's my example. I have a series of pyramids, and I want to know what is the recursive definition. Notice this is going to be slightly different. The recursive formula is slightly different from the recursive definition. We find the recursive formula, and that helps us to create the recursive definition. No. Most of the time, you're not going to have to draw it. Most of the time, they're just going to give you numbers. For some reason, the book is making a pictorial representation of the sequence. So that's actually the first step. The first step is to write down the values. You're not going to be doing that all the time, like I said. Most of the time, you'll just be given the numbers. Okay. Step number 2 is what you want to do is find not the pattern. What you want to see what's happening as we go from term to term. And how you're going to do this is going to change depending on whether the pattern is an addition pattern or a multiplication pattern. Yes?
What is it for me?
That's what we're going to figure out. Thank you for asking. That's what we're going to be figuring out here. Now, if you should start off by seeing if there's a pattern in the differences. In other words, like this problem, I'm going to take the second term. Yes. You take the second term and you subtract from it the value of the second term, I should say. You take the value of the second term and you subtract from it the value of the first term. So the value of the second term is 3. The value of the first term is 1. 3 take away 1 is 2.
You suggest that we draw the boxes for
No, I don't think you need to draw the boxes. I would just write down the numbers. Okay, then you go to the next pair of numbers. You look at the third term. The third term is 6. And you subtract from it the value of the second term. So I subtract 6 minus 3 is equal to 3. And I do the same thing for all of the terms. Now, what the book has in it that I don't is this 6th term, 21. I ran out of room to draw a pyramid with 21 blocks. If you look in the book has a pyramid with 21 blocks. Okay? Does everybody understand what to do? And now I'm telling you that it's not going to be subtraction each time. It could be multiplication, could be addition. In fact, it would be addition if the numbers were getting smaller. What? I'm going to explain it when we do one. Okay, because I've been just throwing one out at the class and it's been a disaster. So we're gonna do another one together, and I'll show you one that's multiplication.
So, why is it?
All right. So now what you want to do is once you want to go from the specific to the general. In other words, all we have for this are 6 terms. So what we want to do is we want to come up with a general formula for this. Okay? So in other words, I want to reduce these to letters, to n's. So what am I doing? So I'm starting off with a sub n. And what am I doing to it? If this is my n, what am I subtracting from it?
Oh, A1.
Well, if this is n, well, what am I doing each time? If I'm starting with the second term, what term number am I subtracting? What am I subtracting from the second term? The first term. What am I subtracting from the third term? The second term. What am I subtracting from the fourth term? The third term. And what am I doing each time? What am I doing to go from 2 to 1? Subtracting how many? To get from 2 to 1, I'm subtracting how many? 1. To get from 3 to 2, I'm subtracting how many? 1. To go from 4 to 3? 1. To go from 6 to 5? To go from n to the next term? So how would I write that in terms of n? I'm subtracting what? A of a sub n minus a sub n is going to give me 0.
A minus.
Not a. Not a.
1 N.
N minus, yeah.
1 N.
N minus 1. If n is equal to the value of my, if n is equal to my first term, what am I subtracting from it? 1 less than that term, right? If I'm starting with 3, I'm subtracting 1 less than 3, which is 2. If I'm starting with 5, I'm subtracting 1 less than 5, which is 4. Does everybody understand what I did?
Yeah.
Is there anybody who doesn't? This is not easy. So, what happens, what do I get after I do this? What is this value the same as? What's that term? What is this number equal to? Yes, it's equal to 4. But where else in this row do you see 4? A? A is A.
A4.
4. So if this value equals this term, this value equals this term, this value equals this term. So this, what should I put here? N. Just N. Because it equals that term. And again, this is going to change depending on what's going on in the problem. Does anybody have any questions? Is there anybody not done copying? All right, so that's called the recursive formula. This is the recursive formula. So the last thing that we need to do is write the recursive definition. Okay? So what we're going to do to find the recursive definition, we're going to solve this, quote unquote, for a sub n. We want to know what a sub n equals. In other words, we want to take this formula and make it into something where now if I just plug in a number for this, it tells me what the answer is going to be. So if I have a sub n minus a sub n minus 1, and I want to get a sub n by itself, what do I have to do? That's right. What am I going to add?
Again.
I'm going to add this, right? Because this is a minus sign. So I'm going to add a sub n minus 1 to both sides of my equation. Remember, I want to solve for a sub n. Okay, does anybody, again, what I want to do is I want to get this, I want to get a sub n by itself. So I'm going to solve for a sub n. That's what I'm doing. I'm solving for a sub n. So now that I've done this, I can write my recursive definition. This is what my recursive definition is going to look like. You state what the initial condition is. In other words, what's the value of the first term? Right, so a sub 1 is equal to 1. If we started off with 4 or 5 or 2, we would write that a sub 1 was equal to whatever that value was. In this case, a sub 1 was 1. The first term was 1.
If you knew that.
And, let me finish. And then we write our recursive formula. So the recursive definition consists of two things: the initial condition and the recursive formula. So if you're asked to find the recursive definition, you can't stop at the recursive formula. You're not finished. You need to indicate what the initial condition was.
So n equals n blah 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 is the recursive formula.
That's right.
But how did you know that a was 1? Oh.
It's the first, it's the whatever's first.
So you just.
Most of the time it's going to be 1, but not always.
Quick question. So you don't have to do all of this. You can just put the first, like the first
Um,
one and then the.
I would suggest doing it so that you really see what's going on. Because it's never going to be more than 4 or 5, a 5 or 6 number. Or it looks like everything is, in some cases there's, 5. There's never more than 5 numbers. All right, does anybody have any questions? Yes, sir.
So this whole question has pretty much three things: find the initial condition, recursive.
Well, the initial condition is given to you. Like I said, and in fact in tonight's homework, there are no blocks. There's only number patterns. All right, let's do one that's multiplication. So example number 2. Okay, so we want to write a recursive definition for this sequence. Okay, now, first thing you have to ask yourself is this multiplication or addition?
Can you tell by just that?
Because that's,
Can you tell by just that number? Or you have to read the proof.
well, the way you can tell is you start off by, you want to know, am I going to be multiplying or am I going to be adding? And the way that you're going to find that out is by seeing if you can get a pattern using subtraction. In other words, start off by doing a sub 2 minus a sub 1. Okay? So a sub 2 minus a sub 1 gives you what? 1. A sub 3 minus a sub 2 is equal to what? 4. And then a sub 4 minus a sub 3. In other words, this term minus this term is 18. Now look at the numbers. Look at the a sub n and look at the value here. There's no, doesn't make any sense. There's no pattern, right? What's going on here? Well, this one is less. This one is 1 more. This is 1 less. This is 1 more. This is 14 more.
Then you get 18.
24 minus 6. It's the value of the fourth term minus the value of the third term.
Oh, so you don't use the little numbers like fourth and
Not
fifth?
till later. Alright, so do you see here? It doesn't make any sense. But, what if instead of subtracting, what if I divided? So a sub 2 divided by a sub 1 is 2 divided by 1, which is what? 2. Now, let's try the next one. A sub 2 divided by a sub 3. A sub 3 is 6. A sub 2 is 2. A sub 4 divided by a sub 3. 24 divided by 6. 4. Ooh, ah. So now, to get now, a sub n, it's not a sub n, it's not that a sub n, right? It's not a sub n minus a sub n minus 1. We tried that. Didn't work. Now what are we doing? We're doing a sub n, what? A sub n divided by a sub n minus 1 is equal to n.
It is going to be a n minus 1.
Yes. You said, is there a reason for it?
No, I mean, there is always going to be a
Yes. Okay, now, to solve for a sub n, what are we going to do?
solve it.
Multiply both sides by a sub n minus 1. That crosses out. So here, my recursive formula, a sub n is equal to n times a sub n minus 1. In other words, to get the value of some term, we take that term number and multiply it by the term that comes before it. Right? 2 times 1 is 2 times 1 is 1 times 2 is 2. To get to the third term, we multiply 3 times the 2 that comes before it. 3 times 2 is 6. To get the fourth term, 24, we multiply 4, which is the term we're looking for, times the number that comes before it.
So can you do that again?
All I do is plug in if n equals 4.
Just put the number 2 on, that's it.
Yes.
Or
Okay,
whatever.
now we just need a recursive definition. So what's my initial condition? A sub 1 is what? A sub 1 was 1. A sub 1 equals 1. And a sub n is equal to n times a sub n minus 1. But this is really the important part, is figuring out what's going on in the problem. as you can see, it's not always going to be simple subtraction. And in this case, it was simple division. It's not always going to be simple division. You have to keep trying different things till you get one that fits. Any questions?